everyone, and welcome to DFINITY Public Global R&D Meeting. I'm Maria. I'm Director of Engineering here at DFINITY, and I will be your MC today. Let's dive into the agenda. We have quite a variety of topics on the agenda today, from core protocol updates and demo for stable structures and vetKeys, to multi-chain topic, which is mostly Ethereum integration today. We'll have an update on Ethereum RPC Canister from Jason, and also Oisy demo from Andronicus. So stay tuned what Oisy is and why it's called like that. And finally, we'll close, last but not least, we'll close up with the exciting community update from Catalyze. It's a fully on-chain social application governed by SNS DAO. So let's kick it off with updates. And Aisling, could you please tell us what vetKeys are, what was the bounty about, and of course, who are the winners? The stage is yours.
More than happy to. Thanks very much for the introduction. And yeah, so I thought I would give a little bit of a overview of what has been going on. I think this is the first time that vetKeys is mentioned in the global R&D in public. So if you've missed any of the communication about what vetKeys is, here's a very brief overview. So we wanted to build some new functionality to let canisters derive strong cryptographic keys. Overall, we want users to safely retrieve keys, sign, encrypt, and do all sorts of fancy privacy enabling stuff. Why do we want to do this? Privacy on the internet is not easy. It's very difficult. It doesn't exist in most of the places we would like it to exist. And so, yeah, we want to facilitate this. Privacy is also difficult. The reason it doesn't exist is because it's difficult. And so, yeah, we wanted to simplify the management of encryption keys and to enable a host of new applications like time lock encryption, MEV protection, and all sorts of fun stuff. How are we going to do this? Well, we made a new cryptographic protocol called vetKeys, and if you scan this QR code, you can see the link. So this so far has been done. If we go to the next slide, we see that the kind of next stage in this vetKey story was doing a mock implementation. So we very much wanted to sort of involve the community in how this feature is designed, how it's integrated, like how it's used, what kind of use cases. We want to design the API so that everybody's happy. And we kind of wanted to do it in stages and iterate so that everybody's involved and get some feedback. So we did a mock implementation of the API that was kind of derived from the paper on the last slide to give a quick prototype to this new key derivation functionality. Why would we do this? So that developers can start building what they want, actually, instead of waiting for the feature to be fully released, so that we can get early feedback from the community on the feature, generally, if they like it, if we should continue, if we should do it at all, and on the API that we propose. And so that then, if the community wants this, and if we do end up integrating this, that there's a bunch of dApps already kind of ready to go once the thing is fully released. How are we doing this? We suggested a new system API. And we made a mock protocol in a canister that implements this same API. This is all done as well now. If we go to the next slide, you see that we wanted to do some bounties. So coming up with a protocol and making a mock implementation is fine. And if you throw it to the wind, you hope that it flies somewhere and that somebody finds it and picks it up. But maybe in order to encourage this, it might be good to have some bounties. And particularly, this is useful in the case of a privacy application or this kind of crypto heavy stuff, which is not necessarily the easiest thing to get your head around. It's not the hello world of, computation. So we wanted some way to encourage developers to kind of participate, to give hands-on feedback, and we wanted to reward them for some early effort. How did we do this? We were graciously granted a $24,000 prize pool from the growth team. And we really particularly wanted to see applications building with vetKeys in 4 different categories: in identity-based encryption, in group sharing, in time lock encryption, and this blue skies open category. These were the things we felt where it's really useful that we hadn't really seen stuff being built before. So if we go to the next slide, The bounties are now kind of done. The submissions have been received. In order for a submission to, let's say, make this list, there were a number of criteria that it needed to achieve, i.e. that it needed to use the API, first of all, it needed to give some feedback, there needed to be an app deployed to the internet computer, it needed to have a demo video. So this was by no means an easy task, and we're super surprised and really grateful for everybody that tried, and for those of the people who are listed here that got through. So if you want, I'll very, very quickly just run through some of the applications that we saw. There'll be some communications highlighting more of these over the next couple of days, but just in a one-liner kind of tweet-sized overview of the submissions, there was Quick, which is a digital document-based proof of personhood system. So they were deriving deriving keys from a MetaMask address and using this to encrypt documents and all sorts of crazy stuff. This was one of the best demo videos. I shouldn't say that we have favorites, but this was a great one. Form Thing, which is an end-to-end encrypted forms on the blockchain, which is like Google Forms but encrypted, so they can't spy on your answers. Rabbit Hole, which exists already, but they added privacy to it. So it's a file service running fully on chain. There's a browser-based AI chatbot, which is served from the IC. Now they used vetKeys to add some privacy. So the chat between the user and the canister is encrypted. Nostric, which is a simple Nostr client running on the ICP. They also used vetKeys to do some key management for the secret keys. MedPX, where you can keep your electronic medical prescription safe and under your control. Capsule, which was a time capsule, dead man switch for files. And just let me note that this is a very difficult thing to do in cryptography generally. And yeah, they did a nice job. And B3Note, which was a note sharing application with witness-like encryption on the IC. And the last one was Guild Notes, so an app for encrypting, sharing role-based content within a gaming community. One thing I should note is that a little caveat is that people should remember that all of these exist now, and there are apps running live on the IC, but it is with this mock canister. So these are not necessarily secure yet, but they are running there. And so if you give me a drum roll and go to the next slide, we can see maybe who the winner is. And I was being a very brutal judge and trying to knock everybody out based on various small, little, insignificant flaws. But Dominic Werner is the kind of hero of all the bounty participants and declared that everybody's a winner. As I said, this was not an easy bounty to participate in. Like the acceptance, like even just to be accepted as a participant was already difficult, never mind trying to understand all the underlying crypto stuff. So everybody that was on that list before is essentially a winner. But some kind of, not some one more than others, but some were much more polished and kind of better understood a lot of the stuff and showcased some of the things. So if we go to the next slide, you see the categories in which we wanted to group people. The main evaluation criteria were around the UX and the design, how it looked, because this is a crypto heavy thing. It's hard for users to know what they need, so you should guide them nicely. Also about the functionality, did you actually understand kind of what is IBE, what is group sharing, what is time lock encryption, this kind of stuff, and then generally the code quality. So if we go to the next slide, we see the winners of the IBE category. So Form Thing was the winner. They had a really nice, the winner like got the first, were ranked in the first place of the IBE category. They had a very nice overall application, very polished, everything worked, everything was very clean. Really nice idea, well executed. And B3Note is the second place. And I must note that one of the things we learned the most from this whole exercise is that everybody applied to say that, we want to be in the IBE category, but these were the only two who actually used IBE. So one of the things that we take away from this is that we're not explaining IBE very well. So that I'll do a follow-up blog post about that. If we go to the next slide, we see who the group sharing winners or ranking are. So MedPX, this medical information privacy application, gets the first place. Form Thing, this is a bit of a plot twist. We didn't restrict submissions to one category. So if you sort of nailed it in two categories, you win in two categories. So Form Thing also did very well on the group sharing. Rabbit Hole gets third place, and Guild Notes, who was a little bit late and who kind of didn't quite get everything right, but for their persistence and actually getting there in the end and really kind of fighting to get something in there, get this kind of honorary position in the group sharing. If we go to the next slide, we see the winners of the time lock. So Capsule, which was the Dead Man Switch and the time lock app, gets first place, and Rabbit Hole gets a second place. And in the last category, if we go to the next slide, you see the Blue Sky winners. So those Quick, which was this proof of personhood app, Nostric, which is the Nostr client on the IC, and the AI chatbot with privacy. So these are the number in brackets is the prize amount. So there was $24,000 split in 4 between the 4 categories. So each category has 6K, and then this is split between the winners or the participants in each 4 categories. So if we go to the last slide, what is next is Dominic will reach out to the winners, which is everybody. We'll share some feedback with the team. So going through the applications, doing the reviews, we found some stuff that we thought would be useful for the teams to know. So we'll share that with those. We'll compile our learnings, the things that you taught us. And I'll do a follow-up to the primer, explaining a bit more what IB is. And now, given the kind of feedback and the interaction between everybody, seeing the direction that people want to go, we can finalize the integration. So we'd like to say thank you very, very much to the Bounty participants for the feedback, persistence, actually getting there, and their contributions to privacy. And a small note to Nathan, who kept the forum alive while the rest of us were away over the summer. And that's it for me. Thanks very much.
Thanks a lot, Aisling, and I'll join Aisling, of course, in thanking the community for jumping in with such cool projects. And also, of course, congratulations to everyone and all the teams. And speaking of Nathan, I guess there will be some breaking news from him right now on the next topic. On the service workers. So Nathan, please give us an update and maybe news many people were waiting for.
Sure. Thanks for the intro, Maria. And thanks for the shout out, Ashley. It was nice to be involved in helping such exciting applications make use of what I think is a really cool feature for the IC. But speaking of cool things, today I want to talk about getting rid of the service worker. But before I can talk about this in detail, on the next slide, I want to talk a bit about what the service worker actually is. So the service worker is an implementation of what we call the HTTP Gateway Protocol. The HTTP Gateway Protocol is what allows standard web browsers to interact with the IC like they would with a standard Web 2 server. And it does this by converting standard HTTP requests into a format that is understood by the IC. It then waits for responses back from the IC. It will verify those responses so that we can make sure that the responding replica is not acting maliciously. And then it transforms those responses back into a universally recognizable HTTP format that the browser can understand. And on the next slide, we can look at the 3 main implementations that we have of this protocol. So we have the service worker, the ICX proxy, and those 2 have been around since Genesis, but the more recent one that we also have here is the local HTTP proxy. So the service worker, this works by when a browser loads up a DApp from the IC, it will request the service worker from the HTTP gateway that resides on the boundary nodes that's running on a remote server. And once the browser gets that service worker, it installs it into the browser, and then any HTTP calls that the browser makes will be intercepted by the service worker, and they will be forwarded as the converted API calls to the API boundary node, which will then in turn forward that onto the network. So the thing that's nice about the service worker is it runs locally. It performs all of those functions we mentioned on the previous slide on the local computer. But the tricky part about the service worker is that it's loaded from a remote server. So you have to trust that that remote server is giving you it's not giving you a malicious service worker. Assuming it does, everything's great. But if it doesn't, then there's trouble. So next we have ICX proxy. ICX proxy runs entirely on the remote server. It doesn't do anything locally. The browser will make the same HTTP calls they will reach the remote server, and they will be forwarded as API calls on behalf of the browser. So in this case, we're trusting the remote server every time we make that call, and nothing's happening locally. But with the local HTTP proxy, this is a desktop application that users can install locally. They can validate that it matches the source code in the GitHub repository. And then while they're using this, all HTTP calls made by the browser will be forwarded by that local proxy straight to the API boundary node. And in this case, we completely skip the HTTP gateway on the remote server. So this is a fully end-to-end trustless solution. Next slide, please. So understanding now what the service worker is, we want to propose dropping support for the service worker as an HTTP gateway implementation. We want to do this because the service worker provides a very poor user experience. It causes difficulty for developers that are developing for the internet computer. It adds a lot of increased complexity, both for those developers, but also for us as the foundation maintaining it, and also anyone else in the community that has contributed to the service worker. And although we've tried over the last year since Genesis, we have not been able to identify a way to resolve this issue of the service worker being loaded from an untrusted remote server. So what we propose is that we make ICX Proxy the default HTTP gateway implementation. And for security conscious users who don't want to trust the remote server, they can opt into using the local HTTP proxy. And next slide. So there's a lot of reasons to get rid of the service worker, and I can't go into detail with all of them, but we released a blog post less than an hour ago that goes into much more detail about this, and I'll also post on the forum after this, so make sure to keep an eye out for that if you're interested. But from a user experience, the performance of the service worker compared with ICX Proxy is not great. It's really impacting every dApp that's on the internet computer. The branding is a problem. The service worker is DFINITY branded, which is nice, but it causes a very inconsistent experience for users. In terms of developer experience, it really just stands in developers' ways. Developers are not able to make true progressive web apps. They're not able to use their own service worker that works under boot scope. They're not able to load web workers in a trusted manner. So removing the service worker just opens up a whole host of new possibilities for developers. Although it's not actually new, it's new for the internet computer, but we're really just making the internet computer closer to Web 2 development experience. And in terms of complexity, yeah, it really just removes just one less component to be maintained in the system, and the service worker was never really intended to be used for what we're using it for. So using more appropriate technology will make all of our lives easier. Next slide. So our roadmap for the next 1 to 2 months. At the moment now, we're putting in some research into how we can more effectively implement the second point, which is to bring the ICX proxy up to feature parity with the service worker. And this is mostly based on 2 points. First being to enforce certification for all API calls. It's currently not enabled for all API calls. And to also strip out any dangerous features that have not been certified. Once we've done that, we want to do some load testing, make sure that we're not going to cause any issues on the boundary nodes. And then we would like to, all going well, make a canary release and ask the community for help with testing this, and to make sure that it's not causing any issues with your applications. And then, of course, if everything goes well, then we want to perform the actual migration to ICX Proxy. And next slide. And then going forward, we want to, make sure that we leverage this choice as much as possible. And caching is going to be a very big one in the future. We want to enable developers to leverage as much caching as they can to really squeeze as much performance out of their applications as they would be able to with Web 2 applications. We want to enable the community to host their own gateways, and we want to continue working on the local gateways and checking out different alternatives that we can make. So that's all from me. I had to run through the slides there because I ran out of time, but thanks for listening, and keep an eye out for the blog post.
Thanks a lot, Nathan. I saw that the blog post link was posted in the chat, so please have a look. And also people say that they've been waiting for more of the service worker their entire life, which is, I guess, we made some people happy here. It's good that we're doing that without compromising on security and features. I think that's what's most important. It's just easy to do something with the consequences, but it's good that we're doing it in a smart way. So thanks, Nathan. And on to the features. In the multi-chain category, Ethereum integration is one of the major efforts. So Jason, could you please give us an update on Ethereum RPC Canister?
Sure, Maria, I'd be happy to. So hello, everybody. I'm Jason, Engineering Manager at DFINITY. I'm going to talk to you about something we're building to make it easier to build Ethereum-based integrations on an internet computer. And what we're building here is an RPC canister. And what it is, it's a managed service that acts as a gateway into EVM-based smart contracts. Why build it? Well, there are several hurdles to overcome when it comes to building a dApp that integrates with an Ethereum smart contract using HTTP out calls. I'll get into some of those challenges in a moment, but the short is that this service is meant to abstract much of the complexity and get developers into the fun stuff much sooner. And how will we do it? Well, I mentioned it's a canister. It'll be put under NNS control, and it will expose an easy-to-use interface. And so essentially, all you have to do as a developer is point your canister at it and fire off your requests into the Ethereum network. So next slide, please. We'll get into some of the current challenges when building an Ethereum integration. So one of those challenges is going to be rate limiting. And that's one of the challenges this RPC canister aims to address. So if you don't use an API key, when you make a call to a provider such as Infura or Alchemy, then rate limiting is performed based on the IP address. So in the case of HTTP out calls, the subnet nodes make the calls, meaning that other canisters on the same subnet could exhaust the request limits by also making HTTP out calls. So you'd get hit back with a 429, too many requests, or get rate limited in some other way. But the short of it is, this could be considered a DOS attack if too many of the same requests are coming from the same IP address. So having an API key solves that problem, but that presents some other challenges. So next slide, please. So when it comes to procuring the API keys and managing the API keys, that's a bit of a challenge. For starters, you need to get a subscription with at least one of the providers. So, there are several providers out there: Infura, Cloudflare, Alchemy. There's a whole host of them. So you'd have to get a subscription, and your dApp would use that. But since the developer controls that account, it would make the dApp less decentralized. Secondly, keeping the API key secret would be the next obstacle. This poses additional complexity for canisters that want to use reproducible builds. So, how do you keep your API keys away from prying eyes? That becomes the second challenge. And then finally, many applications are security sensitive and don't want to trust a single RPC provider to tell the truth. So these canisters want to perhaps query multiple providers, ensuring that they all agree before accepting something as the truth. That means the developer would actually need multiple subscriptions with different providers, which increases the overall cost and raises the barrier to entry significantly. So next slide. So let's talk about what we're proposing to build then. So we are building a single canister that will expose a few key methods. The canister will manage the API keys and represent a number of different providers. So you won't have to think about procuring those API keys and managing them, keeping them secret, so on. You also won't have to think so much about decoding and encoding your requests. The canister is going to abstract away all of that, provide a easy use interface around the request, and it'll perform all the serialization, all the decoding, encoding, and so on. So one of the methods that this canister will expose will be this request method. And what that will do is that'll send a JSON RPC request that includes your payload to an Ethereum node through a provider authenticated by an API key. And then we'll fully, of course, decode the response so that it's useful to you within the context of a canister. You'd attach cycles to this call before sending it, and then you'd get back a response that you can work with right away. Side note, we had to write a lot of code just to decode the responses in our Ethereum starter project, which you can see it's on GitHub. So we think this will be a major value add, just not having to think about the decodings and working through all the code to get a useful response. The second method this canister will expose will be verify message. And again, we found this method useful in our Ethereum starter project, and we'd like to extend it to this canister as well. But we're still sorting out the details here. So the API is sort of shifting a bit, but we'll come to something more solid very soon. Next slide, please. So in addition to the canister, we'd also like to build some libraries. Looking ahead, we want to make it possible for developers to roll their own Ethereum RPC gateway canisters. And to achieve that end, we would publish some crates, ideally into the Ethers ecosystem, that would allow you to manage your own API keys while maintaining the same interface and types that are used by the Ethereum RPC canister. So essentially, you could think of this as a migration. You can work with the Ethereum RPC canister for some time, and as your application or needs evolve, you can roll your own, and you don't have to really migrate your code so much. You can sort of just flip a switch and point to a different RPC canister. We'll be focusing on Rust in the near term because of the popularity of the Ethers ecosystem, but we'd also like to add support in Motoko and possibly through a developer grant, so stay tuned. And next slide, please. So finally, I'd like to hear your thoughts on this. I'll be opening up a forum topic to discuss the interface in more detail. You can find the link to that thread behind this QR code. And if you'd like to be a part of that discussion and influence our design a bit, please head over there and share your thoughts. Now is the best time to provide some feedback while we're still in the design phase. And it's a good time to ensure your opinions make their way into our design. So thank you, everyone. I'll see you on the forum, and back over to you, Maria.
Thanks a lot, Jason. There are a couple of questions on the chat, but I think for the sake of time and giving people time for demos properly, maybe if you could take them on the chat, Jason, if you don't mind. And of course, people are very welcome to post their questions and suggestions on the forum thread as well. So, and let's jump into the action and see some demos. And we'll start with Islam showing us stable storage BTreeMap version 2 update.
Yes, thank you very much, Maria. May I share my screen, please?
Yes, of course.
Of BTreeMap in order to support the unbounded types, while at the same time making it a seamless migration to move to the new version. So there's quite a bit to unpack here. So first, I'm going to begin with a short background on stable structures. So stable structures is a Rust library that provides data structures that would store their data directly in stable memory. So this has two advantages. The first one is that you don't need any upgrade hooks. And the second is that you can take full advantage of stable memory that is 96 gigabytes at this point in time. And so you can scale these data structures to store tens of gigabytes of state. We have a few data structures already, BTreeMap, as I mentioned. We have a vec, log, minheap, and a few others. And the reason we initially implemented this was in the context of the Bitcoin integration. So the mainnet canister that stores the Bitcoin mainnet state currently hosts over 60 gigabytes of state, and it contains BTreeMaps that have over 130 million entries and counting. So stable structures have been working well, and they have been stable, no pun intended, but they do have a challenge in their usability. So consider this very common example where you have a canister and you want to store some user data. So here I have a user ID, some number, and then I have a user struct where I want to store some data about my user. In this case, I just have a short string where I'm storing the user's name, and I want to store the users in a BTreeMap, mapping their user ID to the user. And in order to use stable BTreeMap with these types, you need to implement two things. The first is the storable trait. So this is a trait where you specify how you want your type to be serialized, deserialized to and from stable memory. So here you could use something like Candid or Cbor or Protobuf, whatever would be appropriate for your use case. And second, you need to implement the bounded storable trait. So you need to specify a maximum size in bytes that this type can never exceed. So in this case, a user would have to arbitrarily set some number. So in this case, I have to say a user will never exceed 100 bytes when this type is serialized. And if I'm only storing a user's name, this is probably fine. But as the canister progresses and I want to add more fields, this is going to become a problem. So immediately when people start using these stable structures, they have to think about how much memory they should be giving to any given type, knowing that this number can never be changed. They can never increase this number from 100 to 200, for example. And you might be tempted to think, well, I could just set this to a very large number, like 10 megabytes. But the catch is that we allocate the maximum size in memory for every type. So if you set this to 10 megabytes, then in memory, we would allocate 10 megabytes per user, even if the amount of data that is being stored is very small. So we wanted to fix this problem. So this is the status quo in V1. You have to implement a bounded storable. It needs to have a maximum size. We always allocate this maximum size, which can lead to wasted memory usage. And in V2, we have removed the bounded storable trait completely. And instead, we have added a new attribute to the storable trait, this bound constant. You can choose to specify a bound, but you also have the option to specify or to mark the type as unbounded. And so in that case, you don't have to worry about your type hitting a particular limit before the canister crashing. We have done this with using a very seamless migration, which I'll demonstrate in a second. And it's also much more efficient in memory usage in most of the use cases because we only store the amount of bytes that your data is actually using up. So with that, I'm going to move to a demo. And so here I have a canister. And in this canister, scroll up a little bit. In this canister, I am defining a user ID and a user, just like in the slides that I had mentioned. So I have a user with a name. I implemented the storable trait for the user. In this case, I'm using Cbor, and I implemented the bounded storable trait for this user. And so here I have specified that the maximum number of bytes that this type can have is 15 bytes. And here I've defined the BTreeMap where I'm storing my users. And additionally, I have two endpoints that allows me to insert new users and to retrieve users. So let me go ahead and open up the Candid UI. So this is using the latest version of stable structures. And so here I can insert a user. For example, I'm going to insert Jane, user number 1. And I can query this user as you would expect. But if I were to try to store something that has a slightly longer name, like John Smith, Remember, the maximum size was 15 bytes. What you're going to see is that the canister will panic because we tried to store something that was bigger than the maximum number of bytes that we had initially set. So this is using sort of the old version. And now I'm going to show you how you can upgrade to stable BTreeMap v2 and then reap the benefits of an unbounded. So the first thing I will do is I'm going to go into the cargo toml file, and I'm going to specify the new version. So far, this is on my local machine, but we'll be doing a new beta release of this week. And then in the canister itself, I can delete this bounded storable, trade completely, and I can just specify that this type is completely unbounded. And I'm going to just update one of the imports. And I'm also going to update the candid. Oh, I actually don't need to update the candid file. This is everything that I need. So if I try to compile, this works. Let me deploy and upgrade the canister. So now I have upgraded to the new BTreeMap. That's all the work that would be required by a developer to migrate. And so if I were to try to store John Smith again, which remember crashed because it was over the byte limit that we had, now we're able to store this value. So the size is no longer a problem. So that is as far as transitioning to the new BTreeMap. Some folks have been asking, well, now how do I evolve this schema? How do I add new attributes? And it's really as simple as adding a new field to your type. So for example, maybe I want to add a phone number. I'll mark this as an option. And that's all that I would need in order to evolve my schema. Maybe I'm just going to update the candid because I'm returning this type in my endpoints. So then I can also include the phone number here.
Can I go next, Maria?
Yes, Okay, so for those who wonder who Oisy is, Andronicus will not only tell us, but also show us. So please, Andronicus.
Yeah, thank you. So I'm Andronicus, an engineer manager here in DFINITY. So I'm going to talk about Oisy wallet. So what is Oisy wallet? Is it a mystery shrouded in an enigma, or is it something else? If you press a button, Maria, I want to talk about, yeah, so Oisy is a novel, IC hosted, fully on-chain Ethereum wallet. So that's quite a mouthful. It's rather accurate though, like it is novel. I'll explain that better really on the next slide. You know, it occupies a particular sort of space in Ethereum wallets. IC hosted and fully on-chain, that is rather accurate. You know, it is, this is, you know, we're hosting it here as a set of canisters. It is fully on-chain and it holds native Ethereum assets. And not only does it hold native Ethereum assets, but it can also interact with Ethereum smart contracts. And so this is what Oisy is. What in a name, so it's not a pun on noisy, as some of you have thought. It stands for Open Internet Services. Why? So it really is a play on OIS, which is the core of the work that we do on IC and DFINITY. But more importantly, Oisy.com was actually available. So we registered Oisy.com, and you can go and check the wallet out. So what does it do? It authenticates via internet identity, so you don't need to manage passwords and usernames. You can just use biometrics really to log in. It interacts with Ethereum smart contracts. It supports ERC20 token, and it also supports our very own ERC20 ICP token that was only launched on Sunday evening. So a lot of firsts. And it supports a novel concept that we worked up with Oisy that we call network custody, and I'll talk about it on the next slide. If you press next, Maria. So why did we build Oisy? So it is a technology. It's part really of the bigger vision of IC and cross chain. It fits. It's a core component of the Ethereum integration vision, but it is not. Don't move 100 Ethereum into Oisy just yet. It is really there as a technology demonstrator. For all intents and purposes, it has been tested. We spend a lot of, this is the effort of like 6 weeks, right? So we're operating under a tight deadline, but it was developed in a fast and furious fashion. But yeah, we're very proud of what we achieved as a team. And so why is that it does occupy its own space in Ethereum wallets, and we also thought that it would be a good conduit to generate some noise in the Hong Kong conference that is I think just wrapped up a couple of hours ago. And so we did an airdrop that was also, it was developed in the last 2 weeks. So yeah, it was, and we integrated that into the wallet. And it's also another why is because we wanted to launch ERC, our own ERC20 ICP token, and what a better way to launch it rather than to integrate it into our own wallet. So how do we do it? Like we use under the hood, it really is a technology demonstrator. We're really challenged by Dom to sort of bring all the technologies that we're building in IC together with a very tight deadline. And so we used threshold DCDSA in order to sign signatures. We use internal identity in order to make it super easy to log into the wallet and use it. And we use asset canisters in order to have the code and the assets of the wallet being tamper-proof. Wallet Connect, it is a standard in the Ethereum world, and it's used to connect Ethereum dApps with Ethereum wallets. So we're able to integrate that into Oisy. So we offer like the rich functionality in order to interact with Ethereum dApps. If you go into the next slide, Maria. So a full taxonomy of Ethereum wallets is a rather bold undertaking. So here, I want to really go back to basics, and to going back to basics, you have to ask the question, what are the decisions to design a wallet? And the first decision really is like your target segment, right? It's not a technical decision, but after that, the most fundamental decision is where are you going to store your keys, right? So, that question comes even before you decide the color of your logo, decide what the UX is going to be, where are you going to host it, what you're going to support. Like there's just so many decisions when you decide a wallet, but where you're going to store your keys is a really, really fundamental decision. And in the Ethereum world, you unfortunately face a trade-off. On the one hand, you have custodial wallets that are browser-based. So you can use your browser, you don't have to download anything, but your keys are stored by organizations. So you have to trust those organizations. So we're talking here about like Fireblocks, the wallet in Fireblocks, the wallet in Binance, the Save wallet, for example, and their features set really varies. You know, if you're sort of catered to institutions, then you're just going to have a list of assets. You're not going to allow interaction with smart contracts like Fireblocks, for example. If you're Binance, you're going to allow everything, you know, and then the Save wallet is multi-sig. So, you know, a wide variety of like features, but like its most fundamental is the fact that you can use any browser really to interact with the wallet, and you do not own your keys, right? And if you press next, Maria.
Because we have 2 minutes left.
Oh,
We're in the tight schedule. Sorry.
okay. Okay, so then on the other hand, you have the non-custodial wallets that are where you have to download a plugin or a mobile app, and you see MetaMask, Argent, etc. And so if you press next, then the real value prop for Oisy is that it stands somewhere in the middle, and using TCDSA and internet identity, we're able to build a wallet that is browser-based. You can use any browser in any operating environment that you want to use. It is multi-device. It works equally well on the desktop or on the mobile. It supports the concept of network custody, which is, you know, it's neither non-custodial, it's also not custodial, and it sits somewhere in the middle. So your private keys are really shared in a network. So no one really owns the entirety of your private key. We open sourced it last week, and it also supports smart contracts and biometric authentication with II. I was going to go through the architecture, but maybe I can share my screen and go do a quick demo.
Yeah, really just a minute.
Okay. Okay. So if you can see my screen, sorry, here. Okay, so this is the landing page of the Oisy wallet. I'm gonna log in, so we can see here that the internet identity page opens up. I'm gonna log in with my fingerprint scanner. So what it's doing now is that it is fetching the public key, the Ethereum public key that is linked to my principal. It retrieves that in the UI, and then the UI is doing all hosts of like, you know, a set of like requests into Ethereum providers in order to get the assets that we support and the transactions. Here you see the list of Ethereum assets that we support. We support Ethereum. Here you see the ICP token that we launched only a couple of days ago. It's our own ERC20 twin ICP. What I want to demonstrate quickly is how easy it is to receive from MetaMask. We integrated MetaMask here, so if you don't use MetaMask, you don't see the button. So hopefully you see my my MetaMask window. So with the click of a button, after I confirm, I'm going to transfer 0.05 ETH. And so I'm going to press done, and in about, you know, 6 seconds, you should be able to see the balance being updated. Oisy supports real-time updates. So here you see that it went from 0 to 1 to 0 to 6. So next thing I want to do is maybe I'm going to skip the send. I just want to show you the list that you can click in the Ethereum assets, and you can see the list of transactions. Here you have all the information, transaction details. The interesting thing here is that the status really changes depending on the status of the finality of the particular transaction. Every 32 blocks, the status of a particular transaction in Ethereum changes. So after 32 blocks are called an epoch in Ethereum. On the third epoch, after you're included in a block, the transaction is considered to be finalized. So there is a sense of like probabilistic finality in Ethereum. And so the last thing that I want to show really is the integration with Uniswap. It's just going to be one more minute, Maria. So I go to Uniswap. I'm going to go to Wallet Connect. We register Oisy with Wallet Connect. So we can go here, we can type Oisy, and you can actually see that Oisy is in the list of applications that are the list of wallets that support Wallet Connect. I'm not going to do that now. Instead, I'm going to copy a URL. I'm going to go back to Oisy. I'm going to bring up a model dialog, copy this URL, and now I'm connecting to Uniswap. Uniswap is asking me to sign a message to prove that I am who I say I am. I'm going to approve the transaction, and now I'm connected to Uniswap. You see here that like Uniswap has its own small wallet, and you see that the asset match. I have some Ethereum and I have some DAI. And I'm going to go here. Let's say that I'm going to swap 0.1 ETH into DAI. I'm going to do a swap. I go back to here. I'm going to approve the transaction. And here, what is happening is that, the UI really coordinates everything. So the UI creates the Ethereum transaction, submits it to the backend, which is another canister in the CK-BTC subnet. That canister signs the transaction, returns it back to the UI. The UI then communicates with Infura, sends it over HTTP, and then Infura picks it up and then sends it to the Ethereum network. Right. And so here you can see that I'm poorer by 0.1 Ethereum, and I'm richer by, maybe about, what was it? About 150 DAI. Maybe I'll stop here, Maria, given that we're pressed for time. I wanted to show also the airdrop, but we ran out of time. And just to say kudos really to the amazing team that make it happen. It was a truly collaborative effort. So thanks everyone for your support over the last couple of weeks while we're building this.
Thanks a lot, Andronicus. Please, guys, feel free to check out Oisy online. It's very easy. And I would like to also respect the 10-minute promise that we gave to Catalyze. So I would also like us to stay a couple of minutes longer for this meeting, because we are really thrilled to have Catalyze DAO as our guest today. It's a social innovative application, basically kind of a Discord or Slack alternative for Web3 communities. It has really nice and cool features like organized incentives. And I mean, all the cool things that they're going to show us today. They'll show us roadmap, architecture, and also demo existing and upcoming features. So I'll let Ray, you show the screen directly without me resharing.
Okay. We'll go as fast as we can. I have some kind
it's
of business.
Totally fine. We can run over. Don't worry.
Yeah, I appreciate it, but we have some business preamble stuff in the front that I'll kind of zip through, and then we'll get into the demo and the tech stuff. So let me just get the slideshow going, and then I'll show my screen. Can you see that okay?
Yes.
All right, great. Okay, so I am Ray Laraquenta, the CEO and one of the founders of Catalyze Software, and we're going to do a little bit of, kind of what the problem is that we're trying to address, and then get into some architecture and then the demo, and we'll try to keep it going, because I know you guys have been on the phone for an hour, regardless of the courteous 10 minutes. I want to keep it moving. So we built Catalyze. And just to preface this, we did a lot of work on the back end. So if those of you who've been following our journey, a lot of the stuff that we've done has been architectural on the back end, and the front end has kind of lagged that. So what you're going to be seeing over the coming months is the front end catching up to the back end and activation of more features. But the reason we built Catalyze, we're a team of community leaders, and we watch how Web3 communities have evolved during bull and bear markets. and the tools that people were using were good for audience management and audience acquisition, but they became stretched when it came to what we call self-sustained communities. So the idea behind Catalyze going forward is, how do we create, through technology and tokenomics and incentive systems and tooling, an environment where you go from low engagement, unless you're giving stuff away, low trust if people think they're being rugged, and unreliable community engagement, to something that is more reliable and what I call more self-sustaining communities. And we think that's going to be a combination of feature set as well as data. So, you know, if you don't know me, I'm an ex-Gartner researcher. Data is a big deal for me. And in order to understand why things are happening to you, to your community, having a good source of data to understand why is engagement high or low will allow you to do better programs and activities to drive up engagement. And so what you'll see from Catalyze, not just today, but going forward, is more center stage around data and analytics around communities, not just cool tools and airdrop features and all that, which people love. But ultimately, if you're running a community, whether it's a DApp or a DAO or anything else, understanding why things are happening to you, how you can affect them, is where we're trying to go. So that's kind of a quick, the problem, you know, going from an audience to a community, understanding where the engagement is, where it's headed, why it's happening, and then being able to do something for that to affect it and drive growth and higher engagement. And ultimately, make a community where you as a DApp owner or a DAO owner don't have to, through sheer force of will, keep people talking, keeping them engaged. Everybody has day jobs, and nobody anticipated, you know, living in Discord all the time to keep people chatting about their stuff. So what is Catalyze? So when I started this company with the team, we talked about Catalyze being a Discord alternative, which I really regret, to be honest, you know, because it sets an expectation and it also in some ways kind of, you know, shoehorns you into a very specific narrative. And really what Catalyze is, and even though it has Discord and Slack-like functionality, it's really being kind of rethought in terms of how do Web3 communities exist, interact, how do their cultures evolve, what kind of people are in there, what kind of tools and problems they're facing. So what we've seen with Discord, and to a lesser degree Slack, is that those products have been stretched with add-ons and bolt-ons to allow them to interface with the Web3 technology base, whether it's NFT authentication or what have you. But we still have the same problem that I talked about a moment ago. Discord is a great place for audience acquisition. It's a tough place to create a community unless you can put in a lot of time and effort, give stuff away constantly, and there's a lot of caring and feeding to it. And for small startups and younger DAOs, they don't have the staff for that. There's also new things that Web3 communities are doing that were not designed at the core of those products. And so we can use it as a frame of reference, but we hope that over time, it'll be a new category of itself, which is really a Web3 digital community engine, and not a Discord alternative. But for now, that works. As I indicated earlier, you know, we're going to be a data-driven platform. The analytics is going to play a big part of this. Data dashboards on your community, analytics on you as a participant in that community, and the tokenomic system that we'll unveil as part of our roadmap and activate in the application will feed that data. So people will be doing things that will be rewarded for their engagement that will trigger and create great data so that people who run those communities understand, you know, what is effective, what is not, and they can drive different incentive programs there. Incentive models will be towards incentives and disincentives. So we believe in a stick and a carrot. You get rewarded for being a good community member and driving the community forward. And we do things to disincent bad behavior, toxicity, the things that kind of run rampant on Telegram and Discord, where there's no option but just to mute or block a person. There's no economic cost. So you don't really have a way of teaching people what is acceptable behavior in this community, because all you do is just flush everybody. And then you get a lot of complaints of muzzling and censorship, and that's also not optimal. We already, have launched our SNS, and so, it's a DAO platform. Everything we're going to do is proposal-based. Why we mentioned that in this slide is that part of that data analysis of communities we're going to give people what I would call kind of a maturity model on the preparedness of their community to become a DAO. You know, right now you can create a DAO. Technically, you can create one organizationally, but when it comes to the community part of DAOs, a lot of times there's no community. It's just people who have a common interest, and that's being conflated as community and, you know, loyalty and connection. And so over time, Catalyze will use the data we're collecting on community engagement and maturity levels to help people to determine, you know, should we become a DAO? Do we need our own governance and so forth? So we're going to evolve from a Discord alternative to hopefully a new category of Web3 application is our plan. Moving along, you know, this is where we're going to get into the more technical side of things, and it's going to be a lead into the demo. So Remco, if you would like to hop on, so we give Remco the mic, and he can talk about our data architecture, our application architecture, and then go into the demo itself. Right here, you can see on the right side of the screen the things that we do in the application today and what's coming. So we've got channels and groups, we've got event and calendar management, we have token and neuron gated communities, we have our own wallet, and we support multiple other wallets. I guess Oisy is going to be on the list of things that we have to add to Catalyze very quickly. We support you know, all the tokens on the platform up to CKBTC. Ethereum will be coming as well, and that's there. What will be coming in the future months? Tipping, task management. We've built out, you know, an elaborate airdrop and whitelisting tool, so individual community leads can upload PNGs, mint them in NFTs, and create a whitelist and airdrop it to anybody in their community by role or everyone else. And then we're going to be doing AMA tooling and video conferencing services in the platform, so you'll be able to run everything in platform and not have to send people, go to Twitter for this, go to Telegram for that, go to Discord for this, and you keep sending your people like herds to different technologies. We're going to try to provide that comprehensively in Catalyze. So I'm going to stop there in the sake of time and turn it over to Remco. He can take us through the tech stack and then go into the demo.
Yes. So can you guys hear me? Yeah. So basically, this is the initial setup for the Catalyze backend and the front end. The one thing that changed is that we switched from Svelte to React for the new UI. The rest is kind of the same. So basically, we have the canister that are SNS controlled, and we work with parent canisters that take control of the child canisters. We're now in the talks to move over to stable storage, so we don't have to notice. I don't have to do a lot of scaling, at least not for a long time. Regarding the providers, we use a lot. We support only a few to log into the actual app, compared to using a wallet on Catalyze. Main reason for that is the speed. Like Stoic and Plug create their own actor, but they do some extra steps, which basically isn't good for speed. And next to that, we have some additional canisters like logging canister, storage canister, which works together with the IPFS and the actual matrix server for the chat. Yeah, I think we should just go into the demos because we're already running late. So if you can go to the next slide, Ray. Another one. So we made a selection of things we wanted to show for the new app. This one is the calendar app, which has the week, month, and day view. You can switch every calendar is attached to a group. If you are inside a group, that would be selected by default. If you're an admin or owner of a group, you can create events within this page, as demoed. View. Yep. So basically, this would create an event for a particular group. You can speed it up if you want, Ray. You can speed it to 1.5. Yeah, so basically, this is specific for the event, for the groups, as I told. There's also another option that is private. So basically, if you go from the profile to your calendar, you will see all the events you're attending based on the groups you joined. Yeah, so here you fill in the data that you want, the time, the topics that it's used to, and then it will show like this for the week. We also have like a grid view. So basically, this is a whole new refined based on the previous app with some feedback we got from users. Just going to the different views. This is all pre-recorded, so yeah, and this is the calendar view, which just has the events and the list. So if you could go to the next slide.
Okay.
Doesn't it work?
Hold on for a second. We're having technical issues here. Let me just get to the end of this video clip. There you go. Okay. The next slide.
Yeah, this is the renewed wallet. Basically, at the top right, you see the balance of all your tokens inside your wallet. We have ability to switch wallet, which is different than the wallet from the identity you're logged in with or the identity provider. We also track, or we also show transactions for each token that we have, because the ICRC1 canister allow us to do that. Basically, yeah, here you have the wallet switcher, so you can also see it as kind of a wallet manager to handle your transactions and send and receive tokens. Next to that, we also have some NFT details. One thing that still needs to be implemented is sending the NFT, but this also shows the transactions that happened. And yeah, this is just the renewed wallet, which has improved a lot with the previous app. So if you go to the next one, we have 4 videos in total. Oh, it's just started again. This one is a tipping tool. So this is a thing that allows you to send tips to friends, but also groups. We're also working on a multi-sig wallet that is group controlled. And with that, you can receive tips from different users or groups that also have a multi-sig. So this is just demoing, like, if you don't have significant funds, you won't be allowed to send tokens. If you do, then you can send tips. And after that, we also have like a tip jar, which shows you how much you totally received and the transactions that you got from a tip. So basically, we're using the memo to filter out the transactions that were used as a tip. And above, you see the total received and the total that you sent. Also, again, with a token switcher, right now it's only ICRC1 tokens. And the wallet that you're sending it from, which can be any. Just a quick note is that the wallet that you select within your wallet, or when you interact something with transactions, that is not coupled to the identity you're logged in with. So that's that. And then the last one, which is the airdropping function. Yeah, there's this one. So basically, we have a couple of options to do an airdrop. You can do one to a single wallet, a group event, or a whitelist. In this case, we're going to do the whitelist as an example. You fill in the amount of tokens you want to airdrop in total, and with some math, we decide, with some math and a fee, we say, or we calculate how much everybody is getting. We use Ghost for a lot of things, testing, and Ghost has a fee of one. So basically, if you drop 10 Ghost to 5 people, then you would have not a lot left to send. So this is just creating a whitelist. You select your group, you select the people you want to add, and based on that, you are going to store the whitelist. Then you can confirm, you get a pre-calculation, so what your total is, the network fee, and what is sent, and also what everybody's receiving. This is the demo. So everybody's getting 1.5. Then with the batch transactions, we transact everything, give a notification, show what everybody's getting, give a nice report. Also, with the transactions failed, you can copy it to check if or to redo it, and that's kind of the airdrop tool. We're working on a lot of extra stuff. Basically, yeah, one of the things is multi-sig, boosting groups, etc. But yeah, because of the time constraint, we made a selection of the things that we wanted to show off. So that's it. We can go to the next one. It's starting again.
Yep,
Right.
hold on, yes. We're back to me. Okay, so yeah, so we're a little bit over, so we'll try to wrap it up quickly here. So Catalyze has been in an extended beta for quite a long time. Now that we've gotten our SNS out of the way, we're going to be moving a lot faster. We have been trying to use a relatively tight group of communities and users to get feedback for what we're calling Catalyze 2.0. So here's some of the stats now. Each user is in about 5 or 6 groups. So the total reach of those 6,000 users is about 30,000 people equivalent. But again, we were focusing more on the back end and on figuring out where Catalyze needed to go. And we didn't do a major reach out for growth. Our focus going forward is going to be, like I said at the outset, improve the UI, make it more usable, add out these new features. And then one of the things that's going to be critical for our platform is to release both iOS and Android clients. So once we release Catalyze 2.0 this fall for browser and mobile browser, we'll be kicking off the creation of mobile clients for iOS and Android. And then into 24, we're going to have a desktop client that will run on at least Mac OS and Windows. Because the Discord analogy does have one point that rings true. You need to have the platform in the feature set on the platforms that people use. And so we know a lot of people in the crypto use mobile. They live on phones. So the experience on the phone has to be a lot better than it's been. So mobile device and desktop application support will be coming going forward. You can take a look at this at your leisure. You've got a copy of this, but these are the markets we're going after. When it says top 50 blockchain communities, we mean the top 50 blockchains, not 50 communities across all blockchains. So our goal is to not only be successful in the IC, but to attract a bunch of new users to the IC. And by connecting to them around topics and things they're interested in, we hope to be, kind of the light for the moths to bring them here to the IC. So that's what we mean by that. Gaming is obviously going to be a big part of our community focus. Creators and so forth. And then our heritage, if you remember WEAC a million years ago, we do have, a soft spot for causal work, environmental and things of that nature. And we think that ICP and DFINITY could be a great place for people who are trying to make change at the social level. And we expect to re-up that area going forward. Here's our quick roadmap just to wrap. And so fourth quarter of this year is going to be the new UI, new look and feel of Catalyze. Q1 will be the tokenomics. The airdrop manager probably will come out before that, maybe in Q4, because we've already demoed part of it today. Audio, video, and AMN tooling will come after that. Both streaming channels like Discord, as well as things we're calling like Catalyze casts, which are the Twitter Spaces equivalent. So as you can see here, and I'm not going to read the screen to you, we're going to add features to the tool to address the issue that I raised at the outset, which is for community managers, their goal is to work with their community, not to be vendor relations managers. So having 5 or 6 products to manage a community is not optimal. So we're going to try to provide them with services inside of Catalyze so they can reduce the scope of their technology toolkit as much as possible. And then wrapping things up here, Catalyze can't do this by itself. So as developers, we're going to work with the community to create a developer app marketplace. So services we don't have and are not going to build, we will look for partners to put it in that store, very similar to what Slack does. Whether it's IC-based tools or Ethereum EVM-based tools, we want to have Catalyze augmented with features that are provided by up-and-coming vendors or established vendors who want to have let's call a micro version of their app inside of Catalyze. The analogy that I use, and I'll close with this, you can go to a Starbucks in a street corner and they spend $4 million building the building, or you can go to Starbucks in a mall. Coffee is the same, the experience is a bit different. and you'd be recognized as a brand. And so what we want to do with Catalyze is create a platform for vendors to implement their technology, you know, in a certain way and perspective inside of the platform in the marketplace to enhance the experience for users. And I will stop there and hand it back to you.
Thanks a lot, guys, for cool demo and features. It's exciting roadmap ahead. Thanks also everyone who stayed over time, and sorry about that, but I think the agenda was all worth it. It's pretty exciting, a lot of things moving in different areas. So with that, I would like to close and thank everyone, and we'll see you in the next Global R&D. Have a nice rest of the day. Bye.
Thanks. Bye.